Okay, so just to sort of set some like ground rules here, right? So I have a limited set of knowledge here, which I'm going to be, trying to probe the panel with. So please get your thinking caps on about questions that you want to ask these panelists. We'll try to throw things out so that we can actually get a bit of a discussion going, because it's late afternoon and we've drunk lots of coffee, we've had some sugar, and we've got a good night ahead of us, okay, hopefully. So please remember, the only question that is a stupid question is the one that you did not ask. Okay, so I'm going to kind of start a little bit by maybe challenging our title here around evolving architectures. Okay, so at some point, so I remember going to a supercomputing conference, maybe 10 years ago or something, right? And there was an actual conference track that was around disruptive technologies. And now we're talking about kind of, okay, they're evolving, right? Sounds a little bit less kind of, so what are the things that we really need to worry about? I'm a lazy person, right? What are the things that actually will be disruptive? Or is everything just getting very incremental nowadays? Sadaf.
In fact,
I don't think you need to press the button.
I have the wrong glasses. Yeah. So I in fact chaired one of those disruptive things. The idea there was primarily that the bigger companies can pay for the exhibition space and the smaller ones can't. So the idea was to provide that space, but this was that someone who are, you can call them underdogs. So the disruption for me, I think quantum is a disruption. It's not incremental. And we could maybe ask ourselves a question, whether I did have to press it. No. I switched it off. Yeah. Yeah. Now you're good. I don't read instructions. So we can ask also ourselves whether the use of accelerators back in 2007 or 8, I remember working on those things, and even as early 2000, some of our physics communities are using embedded devices and other things for computing because they were cheaper. So I don't want to offend you personally, so sorry to say it like, we became lazy and we are paying for it. So in Switzerland, for instance, the idea was, yeah, people will write code. This is our IP. And it became sort of something you don't do. Like it was like, oh, you should not rewrite the code. It should be portable and things like that. So right now, I think we're, at least in the UK where we are at, it is disrupting us because we were not ready for it. But if I go to the spirit of your question, in the research community, we need to look for disruptive things because they give us value for money. And the thing we need to invest on is software, because that gives us autonomy, that gives us choices, this gives us power that we retain from one generation of hardware to another, whether it's network, whether it's compute, whether it's storage. So we need to be ready for disruption. It's like, people who, I'm going to use an extreme example. You do not start planning for a disruptive, natural event after it has happened. You do it before, kind of a thing. So I think we should imagine the disruption can come not only from technology, but also other reasons like geopolitical, supply chain, and you name it. But if you are talking purely in technical terms, I don't think it will be incremental, but otherwise it will be very boring. And going to the spirit of this panel, and one of the feedback I'm giving funders here, think about quantum now, don't wait. I mean, I was in fact giving them feedback on thinking about accessing and distributing that capacity already in the programs, not after it has happened and it has been successful. So yeah, that is my personal view. We should be ready and looking for disruption because it gives us value for money.
Thanks for that. Billy, do you want to have any thoughts?
Yeah, maybe I chip in with something different. So what I'm seeing from the cloud native approach is that basically it's about managing change. So these are technologies that are response to an acceleration of change. So the question was, how do we manage it? Can we able to keep up with all of the things that are happening? And they are coming up with interfaces, with abstractions, with different ways to work. And what I'm seeing is that actually means that instead of like moving work to robots that are handling stuff, this actually means that now the work somehow feels smaller. Like you're collaborating with people on things that are running on your system all across the planet. And you're using these interfaces to access these resources. And then disruptions are not things that happen somewhere far away, but rather that are constantly happening all over the place. So I imagine that once that quantum comes in, when it comes, we're probably going to have the type of tools that come from cloud native to be able to integrate those. So you might have sites that are running these simulations, then you have HPC in a different place that is doing the post-processing maybe, or maybe they're sitting together and then the interfaces are gluing all of these things. I see that this is an enabler for disruption. And I think it's a good thing. There is more science being done. So this is positive.
So Viv,
Okay.
sky is still falling in. What's going to keep us awake at night?
New algorithms are disruptive. So hardware takes a little longer to evolve and put in place. And if it disrupts you, you weren't looking, right, as it was coming along. But a new algorithm, someone can come in much faster. And I can think of examples in the condensed matter community, for example, when matrix product states and tensor networks came along, the entire computational community switched pretty much within weeks or months because you weren't competitive if you didn't do that. And then when the using machine learning to prepare your initial state came in, right, everybody had to do it because if you didn't keep up, you didn't have competitive results. And there are examples over decades of that sort of disruption. So AlphaFold was disruptive because the expensive simulations to get the structure out for organic and biological molecules, it gave you good starting points or good guesses for most of them. It's not perfect. How would you know, by the way, unless you've done some hard work to check it? But again, it was very disruptive in sense of the workflow. But so I would look there, and it's disruptive in a good way, as you said, because more science gets done.
Okay, so we're an ambitious group, right? Okay, but our systems are like stupidly complicated nowadays, and we've talked a lot about simplifying a lot of this stuff in order that we can provide accessibility and usability for diverse communities. So, but what is the right balance in terms of how we kind of present some of that complexity that would, that is the kind of nuts and bolts disruptive stuff, and then how much you really just wrap up in kind of like, oh yeah, if you just like click a button there, it'll be fine. Anyone want to say that?
I don't know if you can do really rigorous good science if you don't understand enough about what's going on underneath that you trust the results. So just click a button, it better be on something you have good reason to trust it's doing what you want. The complexity, I agree, it becomes teams, a team operation now to run stuff to really exploit the largest compute that we have. One researcher and their PhD student doesn't do it anymore. And that shift to working in teams is, I think, the thing that is pushing the community harder, because it takes longer for humans to organize in that fashion and produce results.
I will take, I mean, I completely agree. The problems that we are going to solve are also, the simple ones are solved. Or they were not simple when they were solved, but I think it's the value point of view. I think one of the question, in fact, or only question that was asked, is simplifying something for AI community on Isambard AI was worth it? Yeah, because the value proposition was different, getting things going, because if you build an infrastructure, for me, it's very simple, but like, okay, let's just take a scenario, it's complicated. In terms of value to the taxpayer, it starts depreciating as soon as you do it. So if you take a very long time to, so you need to get into the model of where the value is coming from for different stakeholders, different communities, science provider, and you don't wait to get everything perfect in that scenario. And you will have time to understand everything if that is what your mission or so I personally do not think that systems are getting, I think systems are becoming a little bit more transparent and usable from a software point of view. I just think of, as I say, I have been in this community for a long time. Our community never thought about earlier days using Linux as an operating system for HPC. They used to have proprietary, I know some, like especially people who have not done this thing with it, but now no one even, and that gave us a lot of transparency into the environment and other. So for me, systems will get probably, depending on your perspective, maybe they will have more components, more moving parts, but you have better and visible management software. That's why I am really arguing very hard, and I will continue doing so, for completely open source, open standard, from data center all the way to the click button thing. Because it's not the complexity I worry about, it's the opacity I worry about.
Is the what?
Opacity, yeah, you can't
Yes.
see.
Yeah.
And I think in science, and that's why I say, if you then need to check the integrity or reproducibility, all the bits and pieces, which we also these days complain about LLM, you just don't know why it gave you a certain, I'm so sorry, my voice. So yeah, so I would not say like someone looking for a button is doing the wrong thing, or someone writing in assembly. I don't know if someone is writing, but if their heart desires, who cares? It's necessary. From my perspective, I think we should manage complexity by demanding transparency in all bits of software and hardware stacks, I would say.
So I definitely things feel more complex, but it feels that we're building up on the pyramid, meaning that we're building on the work of other people. It's very important to be involved and participate in the communities that are creating these things. In one part, because you need to be represented. Otherwise, your point of view might be left behind about the needs that you have. The things that you care about might not be represented if you are not actively participating on what's happening. And that means that you need to ensure or maybe advocate for investment. And here's not only for money to build systems and to train people, but investment in people themselves. So to ensure that there is a new cohort, let's say, of participants at all levels of the stack, not only people that are building engineers, but also the scientists too. And I think that's important part of the activity that somehow I can see that we forget on trying to get things done. We're just too quick to do things, and we don't think too much about these other soft assets that we should be creating and also taking care of. And I think that's somehow how, as humans, we organize and manage the complexity of things as moving forward. As Sadaf said, things that today we take for granted, 20 years ago, they were bleeding edge of things. And it seems that that's always going to be the same. Like we just keep moving the edge forward. And but we need to do it in this way, meaning organizational, human interaction type of thing.
Excellent. I'm conscious that Brian is standing here ready to run around with the mic. So are there any questions that people have or points that they'd like to raise with the panel? I'll stop touching this because it makes everything go boom when I go do that. Yes, sir.
So just a basic question, how long it will take before HPC is quantum enabled, at least a fraction of that in a production quality system?
If that's like your punchline at the end of your talk, Viv, do kind of shroud it in some element of mystery so you still have the big reveal.
The UK government has a plan. It is on my last slide what those timelines are. And then we can have a discussion over dinner whether we think we can implement their plan and whether they're giving enough resources to do it. But it's soon. It's time to get involved in building towards that. Because it may have consequences on future investment in research and infrastructure if we don't at least take seriously what they think we can deliver.
And I think we'll ask Brian or anyone from NVIDIA to don't hear what I say.
From where?
So yeah, it depends on who you ask, because some people say that you do not need a specific or a specialized hardware, the algorithms, which is good. I mean, there are simulators and emulators, but the reason people will build quantum computer dedicated, at least this is kind of my belief, because I mean, I have been working on a specialized system because they give you a more than incremental, a substantial, a complete step change in terms of the resources do a problem solving. And I think there are some problems which cannot be solved in classical landscape and even in the emulation. However, I still strongly believe, and I've not been that much exposed to, so I attended my first panel or forum or whatever it was called on quantum AI a few weeks ago, and I was so surprised that there is no coherent approach. I said, what are you waiting for? kind of thing. So yeah, we need to start thinking about the investment in software stack. People, no matter what type of resources are available, because like everything else, it may just happen, and then we will be doing the catch-up. If someone wants to be in a leadership position, you invest, you take a risk, and you are ready when it comes. And I can tell from my career experience that always is back. So I will not do prediction because I think I'm not necessarily it's not the right thing to do, and I know very little to nothing about quantum computing. But I think we should really think about that it is going to be whether you end up calling it accelerator technology or something on its own or standalone, it will help us solving the problem or in a very cost efficient and effective way that we can't do with classical computing. So that is the assumption, at least we are working on, and we are working with the government from the competence area we come in. I do not have the competence area in quantum computing.
Any more hands? Any questions? Stay.
Thank you. Felipe and Sadaf have both advocated strongly for the benefits of cloud native HPC in the different approaches that they have taken. I'd like to have a devil's advocate kind of view from you both about what the disadvantages have been and what you found that you've regretted about the approaches that you've taken.
So, do you want to start, Felipe? I can, and then you can think.
Yeah.
Yeah. I don't want embarrassing myself. Yeah. I always say there are scars. It is a huge change management in established organization. That's one thing. So when I was in Switzerland, I mean, and this thing started 10 years ago, because it's a completely different way. Technology is the easiest part. Is the ways of working in a center and what kept us going despite all the and here I'm sort in I'm including CSCS experience in that regard was that whatever we had wasn't working either. It was not helping us grow the business and it was not returning or giving value to our customers or stakeholders or service provider. And for me personally, it was always like, yeah, it is risky, but do I want to? And we always have a fallback plan. You have to have a fallback plan. You can always build, I'm sorry if I'm offending someone, you can always build a cluster. What's wrong with it? But it was, so the thing I would regret as a personal level after almost like 10 years or so, is that I really didn't appreciate at the human and organizational level, it will be so difficult. I should have realized and recognized it. I think our customers or people loved it. It was, it was more where people had a lot of control and fixed ways of doing things. That was really very, very painful. The other thing I would add is, which was, our community is not very good at paying for software. And I think that is, I think now it's getting much easier because now everyone is the model that is. So yeah, I would do it all over again, personally.
Any comment?
So I slightly missed the context. This is the context for AI,
Cloud.
the cloud, or cloud in general. I think the thing we need to watch is the extent to which we have brought the general public, like people, with us on understanding what this stuff is. I mean, there've been at least 10 years of focus groups and publicity and stuff before the hype got so big for quantum, like just checking what people's views are on it. You know, the pluses and minuses of the different technologies, not just computing, but also sensing and timing, and what was coming down the line if, you know, as things became commercialized. And I don't think the same level of care has been taken over what we now have in terms of cloud computing, how much their lives depend on it, what happens when it breaks, like Vodafone broke yesterday, for example, you know, for a few hours. And a lot of people were quite upset about this, understandably, but, you know, many of them would still remember when they didn't have a mobile phone. So the fact they're now so upset about not having one for 3 hours tells you there's, as I say, there's a real sort of public level of assumptions and not understanding how things go. So I think that's the thing that could still bite us quite badly, is not having enough, if you like, public engagement with really understanding what it is we're doing and how it's all interlocking.
Yeah, so in this context, it's on-prem, it's just using the technological stack. It's not commercial cloud we were talking about. But you need to understand how they work also, because if you don't understand, then you're also not making good decisions.
So maybe to add a different dimension and to circle back to something that Sadaf mentioned earlier, there is a very large amount of technologies that are available, and not all of them are open source, and some of them, very useful ones, are vendor provided. And I think that where we're making decisions in order for the convenience of the tooling, we need to be careful about maybe that this flexibility and convenience actually also comes with other costs related to lock-in, for example. And I think in the long-term view, it's very important that the decisions that we're making where we're buying technology is that we actually own it, and it's not the other way around, because that would be one of the long-term pains when you're making this decision. So I think that with respect to the question, like what would be the not so positive things about this, is that just because it has a cloud name at the beginning, the technology is not necessarily good. It might be convenient though. So that's something that we need to be very careful and aware, and to make the proper evaluation. Now, on the other hand, you get flexibility. And here I'm talking about the on-prem and the on cloud ones. So I think the decisions need to be made and be very carefully made. And that's not for free.
Okay, so we have 3 minutes left before Viv takes the stage for real. And I'll just pick up on what Sadaf was saying a little bit about, we've got to think about embracing the quantum sooner rather than later, and these other changes that are about. So let's try to make that like really real, and I'll give you loads of options here, so you can, so if you're an infrastructure engineer and you support, sort of hardware, or if you're kind of a software engineer, or you face some sort of leadership position, or you've got data facing person, or maybe what should we do as a community effectively? What should you give it, seed a few things that say that if everyone could make a comment about what should you try to challenge yourself with if you're in a particular position. So pick kind of one of those facings and maybe give some people some food for thoughts based on their context.
Maybe I can start.
2 minutes.
I'll keep it 30 seconds. No, I think I would like to preface it in the sense that if in an organization you have a running business, so if some of us who were doing earlier GPU acceleration, it doesn't mean we changed everything. You need to get yours depending on your role, but if I was always in a national supercomputing center service provider, you cannot compromise your running services. It is an investment like everyone does on the side, so to speak. So if you do not have any spare capacity, let's just take this scenario, it will be very difficult.
So this is the case for being more experimental and kind of having that capacity to be able to try stuff out.
Or free up capacity. So I think some of these cloud native approaches or operational approaches we do for automation, it frees people up so they can invest in preparing for whether you are doing it at the software and other level. And as an organization, I don't know if it is still the case at CSCS or not, you need to, depending on how you really need to actively reduce the toil in the team in a very proactive and prioritize. And everyone should get 1% of their time for this exploratory stuff, because otherwise it will not happen. So I'm not going to give you like a precise answer, because it's the leadership who should say, it is important for us, everyone gets 20% of their time to investigate this thing, and we would like to answer question like in 5 to 6 months. So that would be the approach we will be taking. So in particular, in our case, we are looking at some of the software stack, for instance, and NVIDIA is providing this kind of.
I'm going to move to Philip. Do you have a seed you want to plant in people's minds?
So in 30 seconds,
Yeah.
um,
Brian's
so
standing.
what I'm seeing is that, and it's not just with quantum, but we see a lot of complex machinery being built. And I think it's more, the challenge is more about how we integrate to work with each other, so to be composable in a way, so and adaptable to these components. So that my question would be, if a facility like this were to exist right now, is that how we integrate each other? Because I'm pretty sure that whatever it's being able to do on that quantum machine will still require interfacing with other things in order to become very useful. And then my interest would be, what are going to be those interfaces, how we're going to interconnect these two sides, because it's not like the previous things just immediately disappears and now you have a completely new future. So it'd be a transition there for integration. And my question then for the people that are participating there is like, where that's going to be, and if you're interested, then try to be involved on creating those interfaces.
So I could ask you, Viv, but you've got a whole 45 minutes to inspire us. And so in the interest of time, I think we'll move things on and thank our panelists very much for just busking this particular panel very well.
Thank you
Well
for
done,
that.
everyone. Thank you.